This video introduces two new stacking rules and two new branching rules. So far, we have seen the two foundational truth tree rules. So we've seen that P and Q decomposes by stacking, like this, and P or Q decomposes by branching, like that. Now what we're going to do is introduce the rules for conditionals and negated conditionals using some familiar logical equivalences. This is going to give us one branching rule and one stacking rule. Let's do the branching rule first. So we know that P arrow Q is logically equivalent to neg P or Q. From the disjunction rule that we have just written down directly above here, we know that the right-hand side of this logical equivalence has to decompose like this by writing neg P on the left branch and Q on the right side. And since that's logically equivalent to P arrow Q, that's going to be exactly the rule we use for dispatching conditionals. So that's one new rule. If your main logical operator is a conditional, you branch and you write the negation of the antecedent on the left and the consequent on the right. Now let's do the stacking rule. Let's suppose we have the negation of a material conditional. We know that this is logically equivalent to P and not Q. And we know how the right side would dispatch. It would stack P on top of neg Q. And since they're logically equivalent, it must be that this left-hand side is also going to dispatch in exactly the same way. So we're going to check it off and stack P on top of neg Q. And that's going to be our new stacking rule. So we're up to 4 rules now. We have 2 stacking rules and 2 branching rules. We're going to do just 2 more. And these have to do with negated conjunctions and negated disjunctions. Again, we'll do the branching one first. We have the negation of P and Q. We know that's logically equivalent because of De Morgan's laws to the negation of P or the negation of Q. So the right-hand side would decompose by checking this off and writing neg P on the left and neg Q on the right. So likewise, the negation of a conjunction is going to dispatch by checking it off and writing down neg P on the left and neg Q on the right. So we're leaning really heavily on our logical equivalences and using them to very quickly generate more truth tree rules for ourselves. Now we just have one left. And then after that, I'll do the biconditional rules. So for the negation of a disjunction, we know that that's logically equivalent to the conjunction of the negations, neg P and neg Q. So again, on the right-hand side, this would decompose in a truth tree by stacking neg P on top of neg Q, which is exactly how its logically equivalent partner has to decompose. So the negation of a disjunction, you check it off and you stack neg P on top of neg Q. And very quickly, we've built up our truth tree rule system so that it can handle almost any kind of sentence we can encounter in our language. There's only 3 kinds of sentences left for us to deal with: a material biconditional and the negation of a material biconditional. Those rules are a little different, so we're going to do them separately here in a minute. And also we need a rule for double negation. But for now, just notice how important the patterns are here. On the left-hand side, I have the stacking rules. On the right-hand side, I have the branching rules, and I have developed these by leaning heavily on the logical equivalences. Now, to move on to the material biconditional, the material biconditional is a little different because the material biconditional rule works like this. I'm going to write it down first, and then I'm going to explain it. It's not difficult to understand, but let me just write it down first. It branches and then stacks. So you branch, and then you stack P on top of Q, and you stack neg P on top of neg Q. And you check off your original sentence. That's the rule for the dispatching of a material biconditional. And you can think about why it must be this way, because if you look at the branches on the left branch tells you that the sentence P if and only if Q is true when both P is true and Q is true, because the P and the Q are stacked on top of one another here. So if you make P and Q true, you will also make P if and only if Q true. The other branch tells you that another way of making P if and only if Q true is to make both P false and Q false. So that one is picking up the last row of the truth table. And remember, what's displayed on the truth tree rule is just the rows of the truth table where the main sentence here that would be defined by its canonical truth table is true. Okay? So now, if you understand that rule, the one for the negation of the material biconditional is fairly easy to understand because it also branches and stacks, but now we have P neg Q neg P Q. Because, of course, since this one is the negation of the P if and only if Q, it's going to be true. The negation of P if and only if Q is going to be true whenever P and Q have different truth values. So the branch on the left, right, if I make a little partial canonical truth table here, the branch on the left here, represents when P is true and Q is false. When P is true and Q is false, the material biconditional is false, so its negation is true. The other branch represents when P is false and Q is true. And that's going to mean that the biconditional is false, but the negation of it is true. Okay, so these are easy to remember because there's a very clear pattern. If you remember that the biconditional kind of selects for when the two sentences have the same truth value, well, they're going to have the same truth value either if P has the same truth value as Q and they're both true, or if P and Q have the same truth value because they're both false. That's what this right branch shows. And the negation of that is when they have different truth values. So the negation of P, if and only if Q, is going to be true when P and Q have different truth values. So you just need one to be true and the other one to be false. And then you just keep the pattern, keep the first one, the P on top, so we make that one false and then the second one true. So that gives us a total of 8 truth tree rules, and there's only one more to learn. It's very, very simple, and you'll soon ask me, I'm sure, why we need it. But it looks like this. If I ever run into a sentence that has 2 negation symbols like that, so that the main logical operator is this negation, and the main logical operator of the component is the next one down here, then what I do in that situation is I check this off, and I write script P. And you might not immediately see how this might be useful, but for instance, let's think of a simple example here. Suppose I have a sentence such as the negation of neg A or B on a truth tree. Now, we've already developed the truth tree rule for what to do with a negated disjunction, right? It's a negated disjunction because the negation is the main logical operator of the entire sentence, and then the main logical operator of the sentence that is being negated is the disjunction. So we go back to our negated disjunction rule. It's right up here. And what we stack is the negation of the P of one disjunct and the negation of the Q. So let me copy that down here where we were working. Our rule for negated disjunction, if I have a negated script P or Q, I'm going to check that off and stack neg P on top of neg Q. And now I just have to match the pieces, right? The neg A here is playing the role. I'm sorry, let me just repeat that because I want to be a little bit more clear about that. The A, we can think of the neg A, right? The neg A is playing the role of the script P, and the B is playing the role of the script Q. And so now what I'm going to write down is the negation here, this negation of the script P. But the script P is neg A. So what I have to write down when I dispatch this sentence is neg A, because I'm writing down the negation, that's the first one, of whatever my script P is. But my script P is all of this in this blue box, this negation A. So that's where I get neg on a truth tree. Okay, that's one case where you can get it. And so I would stack that on top of neg B. And now, in order to be able to see if I have an atomic sentence and its negation, I have to dispatch this sentence with a double negation. So I check that off, and then I write down A down here. And if these had numbers on them, like this, the notation is that lines 2 and 3 came from line 1, and then line 4 came from line 2. So I hope you've enjoyed this video, and next what I'm going to do is some examples.